welcome to another edition of the Code Remix Weekly. As always, I'm your host, Tibik, and with me is my co-host, Sam.
Hello, good to see everyone.
Good to have you back. And with us today is our new colleague, Oleh.
Hey, folks.
So, as always, we're going to take you through a couple of things new with Open Rewrite and Moderne in the past week. And then we're going to do a deeper dive in the topic that we brought Oleh on for this particular subject. So, just a moment as I take you through the things new in the past week. So a first thing that's new is that we are working on a new book that you can read. So if you scan the QR code that is on your screen right now, or go to the bit.ly link just underneath, then you can already register for getting updates on when it is available, and then you can read it. And last week we had Justine on. As you can see, she's one of the co-authors of this book. And it's just, it talks of the various ways that we are using AI for mass scale automated code refactoring and analysis. So should be really, really good. I'm looking forward to having this out and available and being able to hand this out to folks. But if you want to get updated the moment it becomes online, then be sure to have a look at it as well. So another thing that's new is that we put out not one, not two, but 3 new videos on using the Moderne CLI. So if you want to have a bit of an update there, then go to our YouTube channel if you're not already there. And then you can dive into more detail into first getting your CLI set up. Then from there, making sure that you get projects cloned and build those LSTs for those projects, or just download them from the Moderne platform where you can. And from there, skip to running recipes immediately using those pre-built LSTs. So if you go through each of those videos, this is kind of what it looks like. You get a small introduction of exactly how this works in a very brief visual format. So pretty neat stuff. Go explore if you haven't used this yet and you want to know more about how all of this works. So that's 3 videos that are new. Also new as of today is that we did yet another of our 2 weekly releases. So if you want to get the very latest versions of all the recipe modules and all the Maven and Gradle plugins, then you can already go to docs.openrewrite.org to see all the changes that have made it into this particular release. So this is an aggregation of all the changes over the past 2 weeks or so. And you can see that we have a couple dozen new recipes for you to play with. One of the things that is notably new here is that we're now including the Apache Camel upgrades and recipes here as well. So if you have a use case to migrate there, then that should now be very easy by including them in our rewrite third-party recipe module. And then beyond that, we have a lot of improvements as well. So if you maybe in the past have experimented with already upgrading your Spring Boot applications, but have put it off up to now, then you should now see a lot better migrations for Spring Security in particular. For Spring Batch, there's new recipes out there and improved results. And we also have now included the migration from Spring Fox to Spring Doc. And if you are using Swagger still, then those will be migrated to the new Jakarta dependencies. So just as we always do, aggregating all the steps that you might need to do in a larger migration to make it very convenient to run that all at once. So if you had them all up, which we of course regularly do, and you do a Spring Boot 3 best practices recipe run, you now get 2,556 recipes altogether, helping you modernize your application. And I think by the end of the year, we'll probably reach over 1,000 recipes just from our Spring Boot upgrades alone. So pretty good stuff in there. Another thing that's new is that we have continued to improve the recipes that we have for your testing libraries. So that if you're using AssertJ, that we can now collapse consecutive assertions that are just on the same following lines on the same asserted object. We can now collapse those into one, which was very kindly contributed by Smith Mokan. And then apart from that, we also are now more conscious about when we add certain dependencies for Hemcrest where still necessary. And we're gonna inline the Lambda body in assert throws when we can, as well as retain the strictness that you had for Mockito migrations. So in the past, if you migrated from Mockito 2 to 3 and above, you might have found that some tests started to fail because they changed the default. We're gonna keep that default only when you migrate from a very old version to a newer version, such that your tests will still pass. And then later on, you can choose to remove those inserted defaults that we override. So then there's also a couple of recipes in here that we're going to go into more detail later, specifically to run recipes on C# applications. But for that, of course, we're going to first open the floor and introduce Oleh. But for all these releases, as always, you want to go to our rewrite recipe BOM, the bill of materials that we have, where we tell you all the aligned versions to use of all the recipe modules and the Maven and Gradle plugins, such that it all works well together. So have a look at that. I'll share the link in the chat, and then you should be all set to be able to use these latest releases that we have for you here. So that's it in terms of updates for this week. And with that, we're gonna head over to the main topic for this week. So welcome, Oleh. Good to have you on. And as folks might have seen on the intro, that we're gonna talk about the work that you've been doing on our support for C#. So yeah, good to have you.
Well, again, hi folks, everyone, and thank you, team and Sam, for having me. And it's my pleasure talking to this great audience. Actually, it's my first time there, so I'm super excited. And I'm more excited to share the recent work, the recent progress on our expansion toward other languages. And this time I'm going to be talking about the .NET world, the C# world. Well, sometimes I'm joking about it. It's like Microsoft Java. I don't know. But this is a different story. We're not going to be talking about that right now. Well, let me share my screen and probably just show you this. This is the most important, the open source repository that you can look at today. And you can check out it. You can start contributing because it's just great time to start contributing to this repository because it's still in progress and you can add a lot of great things and be part of this great tool. But it's available. But first of all, probably you may wonder how all these great things works, how we were able to integrate this absolutely different world, this .NET written, fully .NET written tooling, and you can just see that we have like 86% of .NET code here, C# code. Well, of course, we have a bit of Java to make both worlds work together, but yeah, it's just C#. Well, to explain how all this stuff works, let me share some slides and share how we've done that. So you're probably aware that in Open Rewrite, we have something called LST. It's similar to AST, which is abstract stands for abstract syntax history. And in Open Rewrite Java, we have some basic, like everything basically covered for Java. So when we were developing this new technology, new C# language support, we were thinking how we can make everything that we've already done available for .NET world, for C# folks, so they don't have to write everything from scratch, like recipes, tooling, integration with our modern SaaS platform, how we can avoid that. So we concluded that basically we can reuse majority of existing Java kind of parts, bits, and just add those things that are missing in Java syntaxes. Of course, C# language is super cool because it brings a lot of syntaxes, sure, it brings a lot of things that are not available in Java, today. Maybe it's going to be available later. Who knows? But everything that is not available is just being added on top, while we still reusing inside C Sharp majority of C Sharp of Java syntaxes, Java elements, etc. So which means that we can run majority of existing Java recipes on C Sharp projects, which is super exciting. Well, you may wonder how we make both worlds play together beyond that. Like, of course, you understood that we reuse our LST model for both worlds, but how it works, how it communicates, because this is C Sharp, this is Java, absolutely different processes. Well,
Yeah.
we,
I
we,
will
we
I will interject briefly to kind of like point out that this extension of the J model with language specific elements is exactly what we did for like Groovy and Kotlin, but those languages, their parsers are in the JVM and are it's not as Groovy you could say is derived from Java, and you might say that about Kotlin as well. Um, so it's maybe expected that they would have a bit more overlap with Java, but with C Sharp, the parsers and compilers and tools for that don't run on the JVM at all. So
yes,
this is
that
maybe a bigger leap.
exactly. We are just to go deeper into that. We are using completely native C Sharp native tooling. We use like Microsoft Analyzer, which is called
Hmm.
Roslyn.
Hmm.
So the Roslyn just parts the whole solution, the whole .NET project. It finds all the sub projects inside it if it has more than one. It parses all the sources and transforms it into our standard representation, into our standard model.
Hmm. Yeah,
And
so
the
we're not
only,
going to
yep,
look inside of rewrite C Sharp and see an ANTLR grammar.
yep. So the only missing bit in this picture is the communication. And in order to make it possible to make like C Sharp doing its work without like involving Java in parsing C Sharp sources, we created our communication protocol. So whenever we send a request, we say .NET, please run a process, create a process for us. This process represents the whole server, which accepts through the TCP different requests. Well, you may wonder the TCP is slow, but we are talking through the local network loop, so it should be pretty fast. Well, in the future, we might use a different transport. It doesn't matter. We created a protocol which is pretty straightforward, and the transport is just nuances of how it sends bytes from one
Right.
process to the other. So it doesn't matter right now. So we send bytes, send requests, and say please parse this project. So we supply the project link. The .NET accepts it, spawn the Roslyn parser, and Roslyn parser just parses project and returns us back all the sources that it found to Java process if it necessary. Well, I'm just talking a bit further about CLI communications, etc. But that's a small concept. The same happens when, for example, we want to do something from the C Sharp. We spawn the Java process and we say, Java, please do this. For example, run this recipe, which is only available in Java because it's written in Java. We parse the sources, serializes the source file, and then it's being deserialized on the Java side, being properly processed, and then returned back. So this is the whole magic in a few words. So this communication happens within the same machine. Of course, it's pretty fast, pretty reliable, and it just works. And it makes completely different worlds talk to each other. Well, I think that it's too much of theoretical things, and it's much better if I can demonstrate something. So let me just share first of all um, our modern CLI platform and just show you that well we already started ingesting a ton of .NET projects. Just a reminder that basically you can go for app.moderne.io. You can sign in using your GitHub profile, and you can get access to the same view as I have. You can find different, well, this is not recipes that I want to find right now, but just organizations with a set of projects. I created a small subset of them just for demonstration purpose. And here I have a couple of things that I want to show you. So, as I mentioned, we can reuse existing recipes on C# projects even today. For example, we can start using static analysis from day one. Here is a small sample of C# static analysis, which is written, all of those recipes are written in Java. And, well, the magic is that all of them just works on the .NET code. Well, it's loading, so we're going to be a bit patient to wait until it appears. But here it is. So this is, I just want to emphasize your attention that this is C# code. Well, it ends with CS, so it should make it clear that this is C# file. And
you see that the function names are in uppercase, which looks so
yes,
strange to my Java background.
exactly. I wanted to make the same joke about that. But anyways, like here is a simple sample of static analysis simplifying redundant intermediate variables. So here in this piece of code, we create a variable and then return this variable. So assignment is apparently not needed. And here we go. Static analysis just simplified that to one line.
And this static analysis recipe is written in Java and entirely predates our support for C#. And this recipe didn't change in particular to support C#, did it?
Say it again.
We didn't make any C# specific changes to this recipe that collapses a variable declaration and a return statement. It's just the same semantics in both languages, so it works directly with no further intervention.
Exactly. Yes. As I mentioned, we are reusing majority of Java model. So like C#, the parts which could be represented in the same way as in the Java represented in the same way in Java. That's why basically all of those recipes which expect specific Java classes or Java expressions works just fine.
So this is great for all the C# developers who were envious of their Java colleagues who were able to resolve their static analysis findings with the click of a button. And we can now do the same on day one that we make this available, just by using the exact same recipes. So
Exactly.
if you in the top right corner, if you click on those three dots to say which recipe made these changes, I think you'll indeed see that it's just the Java recipe that we have.
Let me do that. It hang. Okay. Please. Okay. Now it works. Why did this change? Inline variable.
Yeah, it's the same inline variable recipe.
Neat stuff. Yeah.
Well, a few more things. And I think, Tim, you can help me with that. We have two recipes exactly developed by Tim for C#. And those recipes are dependency insights for C# and dependency vulnerability profiling.
Yep.
So Tim, can you explain what is that?
Yeah, sure. I'll take us through very quickly. So what we've done with, again, using the Moderne platform is that we already have that very nice developer center that you probably know from previous demos that we did. where you can see where you stand on this case on the 109 million lines of C# code that we have in our platform, where there's a total of 461 repositories. And what we can do now that we have them here is that we can look at the vulnerable dependencies being used across all of these projects. So what I've done is we've written a recipe, and we're gonna let's generate this, but I also have the results in the background already, just to avoid the slight delay that we have plowing through 461 projects. So what this does, it runs a recipe that must look very familiar to folks who have watched the show before. The only word that is different in this case is the nugget dependencies. So in the past we had the find and fix vulnerable Maven and Gradle dependencies. We had find and fix vulnerable Node.js dependencies. And now we have find and fix vulnerable NuGet dependencies. So if you take this one, and let's, just for fun, enable these search markers on this particular run, then we can let this run and it will schedule all those 451 projects. You can very quickly see some results on the first one here. Where you see we are using some OpenTelemetry instrumentation version, and this actually has a moderate severity, fixed in version 1.8.1, whereas we are on some release candidate of 1.0.0. So this is the same type of insight that we could already give you for different technology stacks, now expanded to cover the C# technology stack as well. Now, in these cases, we're not yet making those code changes, same as we were hesitant to make larger migrations in the Java world. But we do have some examples here, I think, if we're lucky, to find one where we are actually bumping a dependency version because it's just the patch version being changed. Let's see on this last one. No, all of these are major migrations. So
if you ran it without the search markers, you would only get the code changes, and that might make the help highlight those.
Yeah, so that's what I've done on this particular run, where we are saying, well, only bump the patch version for me. Do not give me any search markers. And in this case, we're fixing vulnerabilities left and right. So this dependency had a vulnerability, this dependency had a vulnerability, this dependency had a vulnerability. All of them could be fixed just by bumping that very last number in the semantic versioning spec. And this just makes your code more secure. And this, of course, is a great help when you run this on a very large scale, which is exactly what this platform is intended to do. So if we go back here and we look across all of these projects, then we also have the option to export a data table to tell you all the vulnerabilities that we have found. And I've already done that, of course, because I'm slightly impatient. Folks that know me will know that. Where here we can tell you exactly that you are using all of these packages, you're using these specific versions of all of these packages, and there is a fix available for these vulnerable dependencies to fix these particular CVEs. And you can see that wherever that column here is true, we are confidently able to make that code change for you automatically. And in those other cases, we will let you know through this export and through a visualization that we can do to notify you that there's probably some high severity, moderate severity vulnerabilities that you might want to resolve. So this is a great start to do these types of analysis. Maybe clear out the first batch of vulnerabilities that you can find. And from there, look at what might be left after this first initial run. And a great way to look at that is through the visualization, which I told you. So here you can see that if we take all the vulnerabilities that we found and you break them up by what is necessary for a fix in the columns here, you can see that a lot of them can be fixed just by bumping that patch version. You can, from the colors, see that we're even bumping, fixing some critical severity issues just by bumping that patch version. And beyond that, there's fixes we can apply by bumping a minor version, or in these cases, we might need to bump a major version. And of course, this is where we want to have recipe coverage to help you across those major migrations. So that's what we're working towards. But all of these 110 or so vulnerabilities you can already fix today. And it's, of course, very neat to be able to finally unlock this to our users. And go explore, go fix things, and look at what you then want to do next. So
Nice stuff.
this is one recipe. Yeah. And then beyond this, you might want to do like a closer inspection on a particular library that you're using, any versions of that library that you want to be are currently using. So with that, we have the dependency insight recipe, this case for C#, and we can run this to look at one particular dependency or a pattern of dependencies, like so, to be able to tell us exactly the versions that we're using of this SDK across our entire organization.
And this is
Maybe
going to
something,
find direct dependencies, transitive dependencies, or both?
For now, this only finds direct dependencies. For transitive dependencies, we need to analyze an additional file, which we of course plan to do next, but we try to make things available to you early and then iterate from there. And then, this is a great help to, if you need to analyze all the versions that you're using of this particular library and you need the answer very rapidly, and we can tell you that right now. So in this case, you're using 17.10 across the board, but we can also give you a visualization that visualizes all of these results. So you'll get that same box jellyfish visualization that we had, or a violin chart.
Box jellyfish visualization? I've usually heard these called violin charts, but did you come up with box jellyfish visualization? Is that your original term?
Ideally, it's a box jellyfish, like heavy at the top with a very thin line going down, as you can see here.
Okay, I see. Hopefully not as poisonous as a box jellyfish.
No. Well, some of these further down might be poisonous, so this is where you want to have this visualization. This one is top heavy, which is good. Not a lot of them are on the very latest version, but of course this is something that we can fix with a subsequent recipe, which we have exactly here. A upgrade to C# dependency versions, where we can say, give me that dependency, and I want to be on 17.11.0. As you can see, the very latest version, and I want to just bump everything up to that latest version. Probably everything in the 17 range would be safe to bump at least. And then from here, we're running this at scale, making changes across the entire org to get you onto newer versions. It's all the things you know and love about using Moderne, now also applicable to your whole C# stack. So just a lot of fun and a couple of recipes that really unlock these use cases already. So that's the things I get excited about and I wanted to show you. And then from here, let's go back to Oleh and see how you can, from this point on, develop some custom recipes to help you with the use cases that you might have.
Well, not just custom recipes. We've been talking about Java recipes all this time. And folks, you can build C# recipes as well with the same way, with the same approach. So if you're familiar with Java recipe development, you're going to be pretty fast on getting on C# recipes development. Well, so let me share my screen and show you this great stuff. Well, I prepared a small project for you folks. Literally, just two things. The recipes and the tests. Well, the one recipe that is already prepared for you folks is really straightforward recipe. Find classes. You all, probably all of you are familiar with this recipe. It's the same as in Java, but written in C# code with C# code support. Well, I'm not going to be spending much time on that. What is an interesting recipe that we want to write is a recipe that help you eliminating some unclean code, unnecessary checks, unclean code, unclean checks. So this recipe gonna help you make your code cleaner and more straightforward for those who are going to be reading it after you. Basically, for those who are going to be reading your tests. And it's probably a common problem when someone tries to write something like that. So we have some statement, and instead of just using assert false, we use assert true and start inverting this Boolean statement. Well, we'll figure out how many places like that are in all of the projects that that are available on the open source shortly. It's still in progress to kind of to run all of those recipes that we prepare on top of 100 of open source projects that are already available at Moderne. But we're gonna start from simple, from this small test. And I just want to pay your attention that the API for testing, for writing testing, is the same as in Java. So you have the write run, you specify the language in which you wrote the specific piece of code, and then the expectation. You can specify a recipe as before, and everything is in the C# world. Well, let me just run it and show you that it doesn't work right now, and we're gonna fix it live together. I will guide you through all the steps implementing this recipe, this useful recipe. But for now, it fails. It says we expected false, but we got true. So it means that recipe does nothing. Well, this is expected. One great thing that I want to emphasize here. This small test spawned Java process to send compiled source file to Java. So the Java can help us analyzing things, can help us scheduling recipes. We can build complex recipe tree. So some recipe is going to be in Java, some recipes in C#, so we can reuse both worlds in the future. And then it returns back the response and supply it to recipe, and we run the recipe and get the expectations. So some details.
Just to be clear, what you're saying is we have not replicated all of the recipe running and scheduling infrastructure in C# and made that able to also run Java recipes, but we are sending this across the wire to a Java process that runs the recipe scheduler in Java exactly as it has always been, and that is able to execute this recipe in C# and get all the results back in one go.
Exactly. Thank you, Sam, for helping me explaining and summarizing everything that I can explain about that. So we keep things simple. We don't duplicate things. We don't increase the amount of code that we have. We reuse everything that we wrote that is well tested and just use it for C# as well. And it just works. Well, the next thing that we should look at is writing the recipe. So this recipe does nothing. It's straightforward. What we need to do, well, the code that we want to fix is really straightforward. So this is assert true, and here we have unary expression, like that. So here we have multiple parts. We have method invocation, we have unary expression, and we have basically identifier which links to a specific variable that we can have in our tests. So if we try to unbox that or like extract all of the things from this specific method invocation, we should probably get an argument which is passed into our method invocation. So we have to go for arguments, and we have to have one argument in it. So this argument have to be unary expression, probably with one n. And for now, this is just expression, because this is just standard Java method invocation. Of course, we have to cast it since we expect that this should be unary expression. And then we can use the same approach as in Java. We can modify our method invocation, and instead of just unary expression, we can replace this argument with identifier, which is available within the unary expression. Of course, this has to be a list of parameters, and this has to be with arguments. And that's almost it. What we have to adjust as well, if we just run this, the outcome is going to be assert true A. So we extracted A expression from UNR expression. But to make it ideal, we also need to go for our name, which is represent basically this part of method invocation, and replace it with false, because we expect that after the test execution we should get assert false instead of true. So we see that like the inversion disappeared, and now we have to replace true with false. So this is pretty straightforward exercise. We just take the existing name, replace it or modify it slightly, and replace it within our method invocation. So what we want to modify is simple name and just put false. That's it. Well, if I just run this, our test gonna pass. Appears, run, pass, please. Yeah, it's passed.
Yes.
Yes. So like this is simple sample. Of course, it's incomplete because we need a couple of more things to make it complete. First of all, not all of the method invocations should be modified like that. That's clear, because this is just a small subset of methods that we want to modify. So we just need to put an if statement that will reject everything that doesn't match an expectation. An expectation is that we're going to be using xunit assert true. Of course, this could be written for NUnit and all other test frameworks that you can find on the network for .NET. Well, we need a couple of extra things here, like we have to extract the name. So just extract name. Here's the function just magically added here. And we also need to check whether the given method invocation actually has unary expression as an argument passed inside of it. So this simple small function gonna help you doing that. We extract from method invocation the arguments, see that the count is greater than 0, check that the first is unary expression. Actually, this could be improved as just this, because in majority of cases it's going to be just one argument. And then check that it's type of unary expression, and check that unary expression is actually inverting things. So we see the not mark on it, and this is a sign that this is the right method that we want to modify. Actually, the same could be written for false statement, assert false that is inverting to true, in all other similar cases. And now you know how to do that yourself. And that's it. It just works. Well, this is a great sample how you can start contributing to C# development's Open Rewrite C# story today and become famous, actually.
Just like us. So famous.
Yeah. But you know, folks, it's not just it. I have one more thing for you. We've been talking about enterprise things. The things that are going to help everyone on the scale. So we have, probably you heard, we have Moderne CLI, a tool that helps everyone today. And this tool is also integrated with all these greatest and latest things that I demonstrated. So even today you can start, I'm sharing my screen, I hope everyone sees it. You can start using CLI. You can start grabbing all of the recipes available on NuGet. Well, you can specify your NuGet source and install all of those great recipes from your specific source. It had to be somewhere there, but whatever. But the most important thing is that you can install recipes from the NuGet. So you can run install NuGet recipe. Basically, this recipe is available on NuGet, the one I show you. It's published over there. I just installed it. Well, this is something unexpected, but this happens during the live demonstration. Folks. That's
Yeah,
fine.
Oleg added this part intentionally to help demonstrate that it's not just a pre-recording, that this is a real live demo on
Exactly.
actively developed code.
Exactly. So this happens, folks. But it should just work on your computer. Just trust me. I'm gonna be skipping installing recipe for any unclear reason it fails. I hope that something that's not gonna fail is the execution of this specific recipe. So just prove that this is the recipe I show you is here. This is your right demo.net recipes invert assertion recipe. The same that I just wrote with you folks. And now it's running on top of C# projects. Well, here we have two C# projects, a Hello World project that I developed for the demonstration purpose, and the one that I've taken from the network, just YouTube downloader. And we are trying to assert true inversion of Boolean variable of false Boolean variable to true, and try to replace all of this assert true with assert false. And we are running this on top of Moderne Hello World. Nothing is found. Why? No changes. So this is live demo, folks. This is literally live demo. It went completely in the wrong direction. I didn't expect that to happen. Literally, I don't know what's going on. Let me do one thing. Let me try to heal all Java. This is something that I love to do, and kill all .NET. Maybe after that it's gonna be better. Let me just rerun that and see whether it works or not. I hope that it's gonna work.
No, if it doesn't work today, it'll work tomorrow.
For sure, for sure, for sure.
And of course, it uses all the same components that we know from the CLI, using those serialized LSTs to be able to skip directly to running the recipes to help speed up development, especially when you're still building out that catalog of recipes that you might have use cases for internally. So it's really helpful to be using these tools as you start to see what you can do with these custom recipes for your own org.
And I still hope that this gonna pass. Otherwise, we just skip this demo, and that's it. The final trial.
Mm-hmm.
Finger crossed. Finger crossed. Recipes are being loaded. Like literally, folks, we are loading the whole DLLs from the NuGet, like the whole world. Store it on your computer. The same happens actually with Maven, and then try to find the recipes within the code base. I don't know what's going on actually. I expected that this one finds something useful. It had to find this. It had to find this. So not today. Not today.
Did you rebuild the LST after adding those two lines?
I did that.
Okay.
I did that. I don't know why it fails. It just worked before. Just believe me.
We're always busy we're software developers. We're always busy putting new bugs into our code as we add features. And I'm sure we'll sort this out later today and have a video, or a recording of the demo working as appropriate, posted on YouTube or somewhere pretty soon. So look forward to that. And yeah, this is really cool stuff, Oleg. It is a real technical achievement, I think, to bridge between these two separate worlds of the JVM and the common language runtime, and shows the path forward for other languages. We kind of started on this JVM island, going to languages that were already there or convenient to access, your Groovy and Kotlin. But now that we've built this capability to bridge out into other ecosystems, well, C# is just the start. There's also Python coming, and then later on JavaScript, TypeScript, and then who knows, maybe insert your favorite language here for whatever we get to after that. But with this infrastructure laid down for remoting between processes and transferring LSTs and recipes back and forth, the door is now wide open in a way that has never been before for expanding language support and providing a native recipe authoring experience as we do, so that we don't have to ask C# developers to write their recipes in Java, or Python developers to write their recipes in Java, or whatever it may be. People will be able to write recipes in the language of their preference and mix and match them with the stuff that comes from all of these other ecosystems. One day, quite soon, we might be running a composite recipe that has subcomponents, some that are written in Java, some Kotlin, some Python, some C#, all operating on and transforming interrelated data models in in a confluence of ecosystems, all towards making automating the tedium out of software development. Really exciting stuff.
Yeah, it's really looking forward to where this will go. It's just
Me too.
bring our existing catalog along and just expand it with the things specific to .NET. Yeah.
Let's see. We have any closing remarks or upcoming events or anything we need to tell the people about, Tim?
No events. No, we'll be back to the regular program next week. But we'll announce the topic this Friday, and then from there, I can once again share the QR code that was maybe only briefly in view earlier on. So if you want to get your hands on this ebook the moment it comes out early September, then this is the QR code to scan. And then with that, I want to thank you both for joining me on this one, and then to see all our viewers next week as we dive into the next topic. So.
Yeah.
Thank you, team.
Oh, I one other thing I just remembered. I will be at Gradle's Developer Productivity Engineering Summit September 24th and 25th in San Francisco next month. So if anyone is interested in those topics that we'll be covering there, the registration is open through September 8th. So you have a week and a half to register. And if any of you catch me there, well, I would look forward to meeting you and chatting with you.
Yes, perfect. Then with that, thank you all for showing up, and then hope to see you again. Thank you.
Thank you, folks.
Thanks so much, everyone.
See
Bye.
you.
Bye bye.